Welcome back, everyone, to my YouTube channel. Today, we're going to talk about how we can use a probability tree to determine compound probability. So, in this particular situation, we have a bag full of cubes, and in that bag, there is a blue and a yellow and a pink cube. So, there are four different cubes. And then after we pick a certain cube out of there, we got to flip a coin, and we either got to land on a heads or a tails. And then finally, we have a spinner with three equal parts that are red, blue, and yellow. And because there are more than three things going on, we can't use an area model. So therefore, we must use a probability tree, which again is a great visual, but in all honesty can be a pain in the rump to actually create. But let's go ahead and take a second and look at this. We're going to look at bag one first because that's the first event. And what events can happen from there? You can get a blue. You can get another blue. You can get a yellow or a pink. And then from each one of those, you can go to your second event and set of events, and that's to flip a coin and either get a heads or a tails, and then a heads or a tails, and a heads or a tails, and a heads or a tails. So just kind of reading through this really quickly, if we look at this set right here, this particular set of branches right here, we can look what happened first. You pulled a blue cube from the bag, and if you go up here, that means you got a blue cube and you flipped a heads. If you go down here, that means you got a yellow cube and you got a tails when you flip the coin. So it's a really simple way to read it. It's kind of like a roadmap or kind of a choose your own adventure book. You kind of go up, and that's the blue and tails. But unfortunately, it's not just two actions. There's a third action in which we got to do a spinner. So from each one of these branches, we got to branch off again and to three equal parts. One, two, three. And that would be red, blue, yellow. One, two, three. Red, blue, yellow. From here, one, two, three. Red, blue, yellow. And from here, one, two, three. Red, blue, yellow. From here, one, two, three. Red, blue, yellow. One, two, three. Red, blue, yellow. One, two, three. Red, blue, yellow. One, two, three. Red, blue, yellow, and you're done with your probability tree. It looks like an absolute mess, but you can actually use it to figure out probability. The first thing is we're going to look for blue. What are we looking for? We're looking for blue, heads, and blue. So we kind of go through and we think anything along this yellow set of branches, we don't have to worry about it anymore. Along with the pink set of branches, same thing, but we have two sets of blue branches that are really important for us. So we go blue, but we want to get a blue and then a heads and then a blue again. So that's one outcome that's helpful for us, right? One outcome that's helpful for us and helps us to win. And then here's the second one. You go to blue again, and then heads again, and blue again. And so we have two outcomes that are positive for us. So we have two blue heads and blue out of, we got to figure out how many possible outcomes, and that's actually pretty simple. You actually just count the end pieces, 1, 2, 3, 4, 5, 6. So we know there's 1, 2, 3, 4, 5, 6 there, 6 there. 3 more would make 9, 12, 15, 18, 21, and 24 outcomes. So the probability of getting blue heads and blue is 2 out of 24, or 1/12 if you want to simplify. 1 win out of 12 chances. And that's pretty much it. Review again, because we know there are 3 actions, we know there's going to be 3 different sets of branches. To figure out the numerator, you just simply read the roadmap and go blue heads blue, because that's what we're looking for in terms of the probability. Find as many of those as possible. We only find 2 in this whole set of outcomes. And how do we figure out the total number of outcomes? You count the end branches. The other thing you can do, which I think is something hopefully you will realize really soon, is you can look at all the possible events here, 1, 2, 3, and 4. There are 4 possible events there. There are 2 possible events here. There are 3 possible events there. And then if you multiply those numbers, that should also give you the total number of outcomes. Because that's how you would find the volume of a rectangular prism is you go length times width times height. So if you think of it in terms of 3D, just like we were thinking about the area model in terms of 3D, it makes a ton of sense. Enjoy your spring break, boys and girls, and I'll talk to you real soon.